There is a photograph taken from the International Space Station, one that astronauts frequently describe as among the most striking images of Earth. It shows the Australian continent at night. Along the southeastern and southwestern edges, scattered clusters of light mark the cities: Sydney, Melbourne, Brisbane, Perth, Adelaide. They glow like embers pressed against the coastline, as if civilization is clinging to the rim of a continent it never fully entered. Beyond those coastal constellations, there is almost nothing. An expanse of darkness so vast and so complete that it appears, from orbit, as though most of Australia simply does not exist. No grid of light. No highway traces. No industrial halos. Just an unbroken darkness stretching across nearly 3 million square kilometers. This is not an absence of geography. It is an absence of people. Australia is the sixth largest country on Earth by land area, covering roughly 7.7 million square kilometers. Its population hovers around 26 million, a figure comparable to the metropolitan population of Shanghai. Most of those people live within 50 kilometers of the coast. When demographic researchers map human settlement across the continent, they consistently arrive at the same startling conclusion. Approximately 95% of Australia is, by any meaningful human measure, empty. But empty is the wrong word. That is the first question this investigation asks. What does it mean to call a landscape empty when it has been continuously inhabited for more than 65,000 years? What does it mean to call land barren when it sits atop one of the most extraordinary concentrations of mineral wealth on the planet? What does it mean to call an ecosystem vacant when it operates as one of the most complex and ancient biological systems in the world? Three questions anchor what follows. Why is the interior of Australia so hostile to permanent human settlement? What actually exists in the space that population maps leave dark? And who, or what, has been shaped by that immensity in ways the rest of the world is only beginning to understand? The investigation begins at the center of things, literally. To understand what the Australian interior is, you have to understand what it once was, and how long it has been becoming itself. Australia is the oldest stable continental landmass on Earth. The geological core of the continent, known as the Australian Craton, contains rock formations more than 4.4 billion years old, among the most ancient exposed surface rocks anywhere on the planet. The Jack Hills Formation in Western Australia holds zircon crystals dated to within 100 million years of Earth's formation. To stand on certain parts of outback Australia is, geologically speaking, to stand on some of the first solid ground that ever existed on this planet. This ancient stability has profound consequences. While other continents have been crumpled by tectonic collisions, flooded by inland seas, and scraped clean by glaciation, the Australian interior has remained tectonically quiet for hundreds of millions of years. The result is a landscape that has been slowly eroding and flattening for geological eons, with nothing dramatic enough to rebuild it. Mountains that once rivaled the Himalayas have been worn to their roots. Rivers have migrated, reversed, and largely disappeared. Soils, ancient and leached, have lost most of the nutrients that continental youth provides elsewhere. The climate story is equally ancient. Approximately 10,000 years ago, a geological blink, the Australian interior was wetter and more hospitable. Megafauna roamed, Diprotodon optatum, a wombat-like creature the size of a rhinoceros, Procoptodon, a giant short-faced kangaroo standing nearly 2 meters tall, Thylacoleo carnifex, a marsupial lion whose bite force rivals any predator in evolutionary history. Lake Mungo, now a dusty archaeological site in New South Wales, once held fresh water. The patterns of ancient riverbeds, visible from satellite imagery across the continent's centre, record a time when Australia had a circulatory system of flowing water that no longer functions. What changed was largely the planet's orbital mechanics, the slow wobbling of Earth's tilt and path, the Milankovitch cycles, combined with the Aboriginal fire management practices that fundamentally reshaped vegetation patterns. By the time European settlement began in earnest, the interior had already completed a long transition into what it is today, one of the most arid and thermally extreme inhabited regions on Earth. But inhabited it has always been. The Aboriginal and Torres Strait Islander peoples represent the longest continuous culture in human history. For more than 65,000 years, They have lived across every ecological zone of Australia, including its harshest interior. Their presence in the landscape is not incidental to understanding it, it is foundational. The mechanism by which the Australian interior maintains its arid character is not simply a matter of low rainfall. It is the product of several interacting systems, each reinforcing the others with remarkable consistency. Australia sits astride a zone of persistent subtropical high pressure, the same belt of atmospheric descending air that keeps the Sahara and the Arabian Peninsula dry. Warm, dry air descends over the continent centre, inhibiting the formation of rainfall-generating weather systems. The closest moisture sources, the Indian Ocean to the west, the Pacific to the east, are blocked or moderated by the Great Dividing Range in the east and by the sheer distance and unfavourable wind patterns in the west. The result is that the interior receives an average annual rainfall, in many regions, of under 200 millimetres. Some areas receive less than 100 millimetres. For comparison, London averages approximately 600 millimetres annually. The driest permanently inhabited place in the world for comparison, parts of coastal Peru, receives around 1 to 2 millimetres, but Australia's interior combines low rainfall with extreme heat in a combination that has few parallels. Surface temperatures in Central Australia regularly reach 50 degrees Celsius. The soil surface itself, particularly on Gibber Plains, the vast sheets of polished pebbles left behind as the fine soil particles blow away over geological time, can reach 70 degrees. There is essentially no shade, no topographic shelter, and no accessible groundwater in vast tracts of the interior. Water is the central variable. The continent does have a river system, the Murray-Darling Basin, but it runs primarily through the southeastern quarter, draining into the Southern Ocean. The interior features several ancient lake systems. Lake Eyre, now formerly known by its Aboriginal name Katie Thander, is the largest lake in Australia and sits approximately 15 metres below sea level. It is, most of the time, a salt flat. Dry. Blinding white. It fills with water less than once per decade on average, when extraordinary rain events send water along the Channel Country river systems from Queensland. When it does fill, it becomes a temporary inland sea, triggering one of the most remarkable wildlife events on the continent: millions of migratory birds converging on waters that existed nowhere a month earlier. This is the interior's fundamental character, not dead, but profoundly cyclical. Not empty, but operating on timescales and scales that human settlement, with its requirements for stable resources and predictable seasons, struggles to accommodate. The cattle and sheep stations that spread across the outback in the 19th century did so by finding the deep artesian water that lies beneath much of eastern and central Australia. The Great Artesian Basin, the largest and deepest freshwater artesian basin in the world, spanning 1.7 million square kilometres. This water, some of it falling as rain more than 1 million years ago, was the hidden infrastructure that made the pastoral industry possible. Without it, even the extraordinary scale of Australian ranching, some stations exceed 20,000 square kilometres, larger than the entire country of Israel, would not exist. In the 1870s and 1880s, optimism about the Australian interior ran high. Land speculators, pastoral companies, and government surveyors drew lines across maps and called it progress. The failure that followed was methodical and severe. The pastoral expansion into marginal interior country coincided with a period of temporarily higher rainfall, a climatic anomaly that convinced settlers the land was more productive than it was. When the Federation drought of 1895 to 1903 arrived, stock numbers collapsed catastrophically. Tens of millions of sheep and cattle died across the interior. Rivers dried. Water infrastructure failed. Entire settler communities were abandoned, their structures left to slowly dissolve into the red soil. The lesson embedded in that collapse was not fully absorbed for decades. The rabbit invasion compounded the damage. European rabbits, introduced to Victoria in 1859, spread across the continent at one of the fastest documented rates of any introduced mammal in history. By 1900, an estimated 4 billion rabbits occupied the Australian interior. They stripped vegetation from vast areas, accelerated erosion on soils already fragile, and created feedback loops of desertification that are, in certain regions, still not fully recovered. The rabbit-proof fence, a structure spanning 3,256 kilometers across Western Australia, was the desperate engineering response to a biological catastrophe. It failed in its primary purpose, though it became one of the defining physical monuments of Australian colonial overreach. The 20th century introduced new forms of occupation, some successful, most ambivalent. The discovery of extraordinary mineral deposits shifted the logic of interior engagement from agriculture to extraction. Iron ore in the Pilbara region of Western Australia, copper and uranium at Olympic Dam in South Australia, gold and nickel at Kalgoorlie, bauxite in the Northern Territory. The subterranean inventory of the Australian interior turned out to be among the wealthiest on Earth. Mining towns materialized in places that had no business sustaining permanent populations. They consumed enormous quantities of water, often drawn from the Great Artesian Basin, disrupted some of the oldest and most complex ecosystems on the continent, and created significant geopolitical and legal conflict with the Aboriginal traditional owners whose connection to these lands predated European presence by many thousands of years. The native title framework, established by the landmark Mabwa decision of the High Court of Australia in 1992 and codified in the Native Title Act of 1993, permanently altered the legal architecture governing who has rights over what in the Australian interior. The decision overturned the legal fiction of terra nullius, the colonial designation of Australia as effectively unoccupied prior to European settlement, and forced a reckoning with the reality that the interior had never been empty in any meaningful sense. The biodiversity of the Australian interior exists in a state of elegant extreme adaptation that mainstream ecological discourse has been slow to fully appreciate. Australia's continental isolation, separated from the Gondwana supercontinent approximately 45 million years ago, meant that its fauna evolved independently, developing solutions to evolutionary pressures that have no direct parallels elsewhere. The marsupial mammals, which retain their young in external pouches and invest far less biological energy in gestation than placental mammals, are not evolutionary relics. They are highly specialized survivors that have outlasted virtually all of the placental megafauna that existed alongside them. The interior's reptile diversity is globally exceptional. Australia harbors more than 800 species of reptiles, the highest count of any country. The thorny devil, Mollicoridus, has evolved a network of microscopic grooves across its skin that channel water through capillary action directly to its mouth, a hydrological system grown into the body. The parenty, Australia's largest monitor lizard, can survive in territories of several square kilometres, tracking seasonal resources with a spatial intelligence that ecological researchers continue to find surprising. The desert interior is not ecologically thin. It is ecologically specialized in ways that took billions of years of geological and evolutionary pressure to produce. The Spinifex grasslands, which cover roughly 25% of the entire continent, are the most extensive Spinifex ecosystem on Earth. These grasses, belonging primarily to the genus Triodea, have developed silica-hardened leaf structures that render them largely unpalatable to most herbivores while simultaneously providing shelter and seed resources for hundreds of small mammal, reptile, and bird species. Their role in the carbon cycle of arid Australia is increasingly the subject of serious scientific study. Preliminary research suggests that the dormant microbial communities in arid Australian soils may constitute one of the largest carbon reservoirs yet documented. Indigenous land management, specifically the practice of mosaic burning, setting controlled fires across fragmented patches of country to promote new growth, manage fuel loads, and cycle resources, has shaped the visual and ecological character of the interior for thousands of years. When European settlers suppressed this practice, fuel loads accumulated and catastrophic fires became more frequent and more severe. The 2019 to 2020 Black Summer bushfires, which burned more than 18 million hectares and killed an estimated 3 billion animals, represented in part the consequence of decades of disrupted fire ecology. Several ecological researchers have characterized the scale of that event as a civilizational failure of land management, not merely a natural disaster. There is a persistent conceptual error at the heart of how the Australian interior is discussed in international media, in policy frameworks, and even within Australian civic culture. It is the assumption that empty land is wasted land, and that wasted land should be put to work. This framework has driven proposals to flood the interior with desalinated seawater, to establish high-intensity solar and wind energy precincts across the desert, to grow food using hydroponic systems at industrial scale, to build nuclear waste repositories in remote strata, and to construct entirely new cities to redistribute Australia's heavily coastal population. Some of these proposals have serious scientific merit. Others are projections of industrial ambition onto a landscape that has already demonstrated, repeatedly and decisively, the consequences of misreading its capacity. The narrative of emptiness has also served specific political purposes. The Australian nuclear weapons testing program conducted by the British government between 1952 and 1963 at Maralinga and Emu Field in South Australia was justified, in part, by the characterisation of the test sites as uninhabited desert. Aboriginal communities living in and moving through those areas were not adequately evacuated. Some were not informed at all. The contamination, including plutonium dispersal from minor trials that persisted in the soil for decades, was real, documented, and deeply consequential for affected communities. The British government undertook a partial and controversial cleanup between 1994 and 2000. The Australian Senate inquiry of 1985 characterised the management of Aboriginal people during the testing program as ethically unacceptable by the standards of the time, let alone the present. This is the deeper truth that the myth of emptiness produces. It erases the people, the history, and the ecological complexity of a landscape to make it available for users that serve interests elsewhere. It converts inhabited country into a resource base, and then, when the extraction is complete or the project fails, leaves behind the consequences. The concept is not unique to Australia, but Australia provides one of its most stark and well-documented examples, precisely because the scale of the interior makes the claims of emptiness initially plausible and the consequences of acting on them almost impossible to conceal. What comes next for the 95% is no longer theoretical. Several forces are converging simultaneously, and their interaction will determine the character of the interior for the coming century. Climate projections for Australia are among the most severe in the developed world. The Bureau of Meteorology's most recent long-range assessments indicate that the interior will experience a significant increase in the frequency and duration of extreme heat events, a reduction in average rainfall across the southern interior, and an increase in fire weather severity. The megadrought conditions that are projected to affect southeastern Australia will place extraordinary pressure on the Murray-Darling Basin, which is already overcalicated and functionally degraded in significant sections. The groundwater reserves of the Great Artesian Basin, drawn down continuously since European settlement, are not unlimited. Several bores have already failed. The recharge rate of the basin, the rate at which ancient rainfall replenishes the system, is estimated in some scientific models to be multiple orders of magnitude slower than the current extraction rate. Against this, the renewable energy potential of the Australian interior is genuinely extraordinary. The solar irradiance values across central and northwestern Australia are among the highest on Earth. The feasibility of large-scale solar and wind installations is not scientifically in doubt. What remains unresolved is the question of land rights, ecological impact, community benefit, and the infrastructure required to transmit generated power to population centres. The proposed Australia-Asia Power Link, which would transmit solar energy generated in the Northern Territory to Singapore via undersea cable, represents the most ambitious version of this vision. If completed, it would be the longest high-voltage direct current cable ever built. The governance of the interior is also shifting. The strengthening of Indigenous land rights through native title determinations and Indigenous land use agreements has progressively transferred legal control of significant interior areas back to Aboriginal communities. The Indigenous Protected Areas program now covers more than 67 million hectares. Research into the ecological outcomes of Indigenous managed lands compared to government-managed conservation areas consistently finds that traditional land management produces superior biodiversity outcomes at lower cost, though the scientific consensus on this is still developing. There is also the question of what the interior means as a scientific resource. The extreme age of the rocks, the isolation, the lack of electromagnetic pollution, the atmospheric clarity, these properties make certain parts of Australia uniquely valuable for scientific purposes that have little to do with traditional resources. The Square Kilometre Array, the world's largest radio telescope project, is being partially constructed in the Murchison region of remote Western Australia, chosen specifically because of the radio frequency quietness of its location. The interior's emptiness, in this context, becomes an instrument. Stand at the edge of the Nullarbor Plain on a night without moon. The horizon is perfectly flat in every direction. The sky carries more stars than the human visual system can properly process, not because there are more stars, but because there is nothing on the ground to compete with them. The silence is not peaceful, exactly. It is absolute in a way that civilized landscapes rarely achieve. It presses against perception like water pressure at depth. What surrounds you in that moment is not nothing. It is 65,000 years of continuous human presence, the longest unbroken thread of human experience anywhere on the planet. It is 4.4 billion years of geological accumulation. It is a biological web of adaptation and survival built across evolutionary spans of time that dwarf the entire history of human civilization by factors of magnitude. It is the trace of inland seas, the bones of megafauna, the root systems of spinifex holding soil that would otherwise lift and disperse on the thermal winds. Australia's interior forces an uncomfortable confrontation with the assumptions embedded in how civilization understands land. The dominant framework equates value with productivity, and productivity with density, of people, of infrastructure, of economic activity. By this measure, 95% of Australia is, in the bluntest sense, failing to perform. But land does not perform. It exists, on its own terms, across scales of time and complexity that economic frameworks were not designed to accommodate. The interior of Australia is not a problem awaiting a solution, not a frontier awaiting settlement, and not a resource awaiting extraction. It is, instead, a record of time, of life, of climate, of endurance, that modern civilization has consistently struggled to read because it does not resemble anything that civilization has historically produced. The real question embedded in that dark expanse of nighttime Australia visible from space is not what could be done with it. The more honest and perhaps more urgent question is whether a civilization capable of illuminating every other part of the planet might finally learn something from the places it has not yet managed to destroy. That knowledge is already there. It has been there, accumulating, for longer than any living culture anywhere else on Earth can claim to remember.